Good morning, guys. Today we're going to be talking about solubility curves, which are based on the concept of solubility that we talked about yesterday. And if you remember yesterday, we talked about solubility, or solutions, have two parts: the solute, which is being dissolved, and the solvent, which is doing the dissolving. So yesterday we talked mainly about sugar being dissolved in water. And we talked about the sugar being dissolved in water is dependent on the temperature. You guys told me that the warmer the temperature was, the warmer the water was, the more sugar I would be able to dissolve in that solution. And so if we actually graph what that looked like, which we did not talk about yesterday, temperature in degrees Celsius would be on the X, and the amount of sugar or solute would be on the Y. And so what you guys told me was, as the temperature increased, the amount of sugar that would dissolve would also increase. And so you would end up with a line on this graph that would create an upward curve. Now, the more soluble something is, the more of a slope that line is going to have. And the less soluble a substance is, the lower the slope will be on that line. So this is an example of a graph, a very generic graph for a solid dissolving in water. Now, we did not get to talk about gases yesterday, so let's talk about gases for a minute. Gases will actually dissolve better. So here we have gases will dissolve better at a lower temperature and higher pressure. So if I were to make a graph for the solubility of a gas, it's going to have to be a tiny one here. Temperature in degrees Celsius and the amount of gas we'll put here. And so I said the amount of gas that will dissolve will increase at a lower temperature. So the lower the temperature, the more gas is dissolved. So this type of graph will actually look like this. So the warmer the water, the less gas will be dissolved in it. So think of this in terms of a fish kill. On a very hot day, or the hottest part of the day, there is less oxygen dissolved in a pond, river, lake, or stream when it's hotter. And so fish will go deeper into the stream, river, or lake where the temperature is colder and there's more dissolved oxygen. So these are the basic parts of a solubility curve. Temperature is always going to be on the X, and the amount of solute is going to be on the Y. Here is an example of a solubility curve. This shows you how soluble salt and sugar are at different temperatures in 100 milliliters of water. 100 milliliters of water, if you remember density, is the same as 100 grams of water, because the density of water is 1 gram per milliliter. So we're talking about the amount of solute, the amount of salt or sugar that will dissolve in 100 grams of water. Which one of these appears to be more soluble in water? Hopefully you said the sugar. Sugar is more soluble in water. Look at the line. Yesterday in class, I had water that was 30 degrees Celsius. At 30 degrees Celsius, look at the amount of salt that can dissolve. I'm right here. Almost 50 grams of salt. Compared to the amount of sugar, which is over 200 grams of sugar will dissolve at that temperature. So each of these substances has a different solubility in water at different temperatures. This is a physical property. Solubility is a physical property, and it's very dependent on temperature. Let's talk about some information that we can get from this graph. Okay? You might be asked questions like, at 40 degrees Celsius, how much sugar could be dissolved in 100 milliliters of water? So how are we going to do this? You're going to find 40 degrees Celsius. You're going to follow this up to the amount of sugar, and then you're going to go over and you're going to read your y-axis. So I would say, based on this data point, we're a little over 225, so 230 grams would be a good estimate here. So your answer then would be 230 grams of sugar. Let me erase this. Or not. Let's try another question. Let's say that I have 300 grams of sugar. I have 300 grams of sugar. And I am going to dissolve this in 100 grams of water. My question would be, what temperature does the water need to be? So I am going to find my 300, which I've already done. I'm going to go over to my sugar, where my sugar crosses the 300, and I'm going to follow this down. And I'm between 60 and 70. So here's 60, here's 70. My line is crossing right between there, so I would say 65 degrees Celsius. The temperature needs to be 65 degrees Celsius to dissolve 300 grams of sugar in 100 grams of water. With these graphs so far, all that we have talked about is making a saturated solution. Any point along this line for the sugar, or any point along this line, which is the salt, is a saturated solution. That means that the maximum amount of solute, sugar or salt, is dissolved in 100 milliliters of water at a given temperature. Well, what if you are below the line or above the line for sugar? So let's pick a data point here. Let's say that at 60 degrees Celsius, I dissolve 150 grams of sugar. So I'm right here on my graph. Can I dissolve more sugar at 60 degrees Celsius? Yes, I can. So any point below this line for sugar, any point at all below that line, is an unsaturated solution. Any point below that line. Let's do that again. Let's pick another point. Let's say that at 20 degrees Celsius, I have 100 grams dissolved. So I'm right here on my graph. I am below this saturation point. So I would have an unsaturated solution. I could add more sugar and it will dissolve. So what does it mean if I'm above the graph? Well, any point above the graph, above the line, any point on the graph above this saturation line would mean that I have a super saturated solution. Let's look closely at a supersaturated solution. Okay, so we're going to look just at supersaturated solutions. Supersaturated, if you recall from yesterday, means more solute is dissolved at a temperature than there should be. Okay? So let's say that at 40 degrees Celsius, I have 300 grams of sugar dissolved. Well, how on earth did that happen? Saturation is right here. This is my saturation point. At 40 degrees Celsius, I should only be able to dissolve about 230 grams of sugar. But I don't have 230 grams of sugar. I have 300 grams of sugar dissolved. So how did that happen? Well, whoever made this solution must have heated the water to about 65 degrees or even greater than 65 degrees. So we heated the water to 65 degrees or more. We put in the 300 grams of sugar, and then we carefully cooled it. And so as that water carefully cools down to the 40 degrees Celsius, we would end up with a supersaturated solution. We would have more sugar dissolved at 40 degrees than we should have dissolved at 40 degrees. That is a supersaturated solution. And that, again, would be any data point above the line. The previous slides, we looked at sugar and salt solubility. Solubility curves are typically a little crazier looking than just salt and sugar. This is an example of a solubility curve that shows you the solubility of sodium chlorate, potassium nitrate, potassium bromide, and sodium chloride. All of you should have been able to name these substances except for sodium chlorate based on our last unit. Which one of these substances do you think is most soluble in water? You should have selected sodium chlorate or potassium nitrate because the slopes of these lines are nice and steep. Which substance do you think is least soluble? You should have selected the sodium chloride. Notice again, my X is temperature and my Y is solubility in 100 grams of water. Solubility curves are typically in 100 grams of water, which is the same as 100 milliliters of water. We're going to do another practice problem here. So let's say that I asked you to describe the solution as supersaturated, saturated, or unsaturated. We're going to talk about potassium bromide, okay? And at 80 degrees, I am going to have 50 grams dissolved. So 50 grams at 80 degrees Celsius puts me right here on the graph. Would that solution be saturated, unsaturated, or supersaturated? You should have selected unsaturated because I can still add more to this. The other way you can tell is that this data point right here this data point is below the saturation line. Anything below this line, anything below that line is going to be unsaturated. Anything on the line would be saturated, and anything above the line would be supersaturated. This is the solubility curve that you should have on the worksheet in front of you. If you do not have these worksheets yet, pause the video and hand these worksheets out now. In this worksheet, you have 3 compounds. How do you know they're a compound? We have a metal to a nonmetal, a metal to a nonmetal, a metal to a polyatomic ion. All of these are compounds. They are ionically bonded. You should be able to name all of these. Try to name this one right now. Potassium nitrate. Try to name this one. Potassium chloride. And try to name this one. Sodium chloride. We're going to use this graph to answer the 6 questions that are in front of you. Some of these 6 questions are very straightforward and you're simply reading the graph. Others, like number 4 and number 6, are going to require some math. So please get out your calculators now and be prepared to cross multiply. Let's start with number 1. Number 1 says, what mass in grams of potassium chloride, so I'm looking at potassium chloride, will dissolve in 100 grams of water at 80 degrees Celsius? So I'm at 80 degrees Celsius. Remember, any point on this line means that I am saturated. So I'm going to follow this up, 80 degrees. How much can dissolve? Follow it over, 50 grams. 50 grams of KCl. Make sure you label your answers. Number 2 says, to what temperature would you need to heat 100 grams of water to dissolve 120 grams? So we're at 120 grams, and we're talking about potassium nitrate. So 120 grams, I'm going to follow this over. I end up being between 60 and 70 degrees. So that would be 65 degrees. So you would need to heat the water to 65 degrees Celsius. Again, labeling your numbers. Okay, we cleaned off the graph. We're going to take a look at number 3. Number 3 says 20 grams, so my y-axis, 20 grams of sodium chloride, 20 grams of sodium chloride is dissolved in 100 grams of water at 90 degrees Celsius. So 20 grams, 90 degrees Celsius. Think to yourself, I am right here on the graph. Before we go any further, I want you to ask yourself, is this unsaturated, saturated, or supersaturated? My line means I'm saturated. Remember, anything below the line is unsaturated. So this is an unsaturated solution. Again, my data point is right here. Continuing with the question on the worksheet, how many more grams of sodium chloride should be added to make a saturated solution? Well, I have 20 grams, and saturated looks like it is 39 grams. So 39 grams is saturated. I have 20 grams. You're just going to subtract. 19 grams can be added to make the saturated solution. We're going to skip 4 for right now because it involves the cross multiplication, and number 5 is actually similar to number 3. So let's talk about number 5. Number 5 says that at 40 degrees Celsius, 60 grams, so I'm right here, 60 grams at 40 degrees Celsius of potassium chloride is dissolved in 100 grams of water. Always 100 grams of water. This is done by heating and carefully cooling the solution. So I had to heat this up to a point that's even off my graph. I had to heat this greater than 100 degrees Celsius in order to make this solution happen. So I heated it, dissolved my 60 grams, and then I carefully cooled this solution down. So I carefully cool it down to 40 degrees Celsius. The question is, if I agitate this solution, like I did the hand warmers in yesterday's demo, how much of this is going to fall out of solution? So my saturation point is right here. Saturated is 40 grams. Okay? Saturated is 40 grams. Saturated equals 40 grams. But I have 60 grams that are dissolved. So if this is agitated, 20 grams would precipitate out, which means to fall out of solution. We're going to do number 4 now, and we're going to skip number 6 because I want you to have time to work. So number 4 says, what is the minimum mass of 90-degree water? So here's my 90-degree water. Needed to dissolve 20 grams of sodium chloride. So we need to talk about what is saturated. Okay? Saturation here for sodium chloride is 39 grams. 39 grams in 100 grams of water. 39 grams of NaCl in 100 grams of water. My question says, what is the minimum mass of 90-degree water? So what I want to know is, how much water do I need to dissolve the 20 grams of sodium chloride? It's a ratio. I do not have 39 grams of salt. I only have 20 grams of salt. So how much water is going to dissolve or saturate this 20 grams of salt? Well, we cross multiply here. 39x equals 20 times 100. 39x equals 2,000. I divide by 39 on the left, so I have to divide by 39 on the right. And when I do that, x equals 51.28 grams of water. So if you're asked how much water, or what the minimum mass of water needed to dissolve a substance is, you first are going to have to find the saturation point. You're going to have to find the saturation point, which is 39 in 100 grams of water. Then you have to look at what you're given. How much do I actually have? Well, in this case, I had 20. But what I don't know is how much water that 20 grams will dissolve in. This is the hardest math problem that we will do in this section. Tomorrow you will be doing a lab. You will be figuring out a solubility curve for succinic acid. There are 3 temperatures that we will use tomorrow. Some of you will have water that will be kept at 45 degrees Celsius. A couple other groups will have water at 55 degrees Celsius. And a third group of people will have water that is at 65 degrees Celsius. Succinic acid is a solid. Succinic acid. So what do we know about the solubility of a solid as temperature increases? Hopefully you recall that as temperature increases, solubility should also increase. So the warmer the temperature, the more succinic acid should dissolve. Please, for the lab tomorrow, you need to complete the pre-lab, both sides of the paper, and within the lab itself, you need to complete the introduction. There are 2 questions there. What is the formula for succinic acid? And you need to define some terms: solute, solvent, saturated, supersaturated, and unsaturated. It also references page 57 in your textbook, and on that page you should find the chemical formula for succinic acid.